Hello and welcome to our lecture. My name is Miracle Chibuzo Marcel and I'm the founder and the director of the Pan-African Citizen Science E-Lab. I want to especially thank the Free Astro Science for sponsoring this lecture. So today we are going to the second part of our lectures on the Introduction to the Moon, Part 2. So for the table of content, I'm going to talk about the lunar regolith and its connection to helium-3. I'll talk about some moon physical properties, talk about the far and near sides of the moon, moonquakes, lunar poles, water ice, moon's magnetic field, and lastly, I'll talk about human lunar exploration. These are all part of my, my last lecture on the introduction to the moon part 1, which I could not finish. So today I'm going to be rounding them up. And I want to also want you to know that this lecture might take longer than expected because I'm going to be sharing a lot of information and with a lot of graphics. So the lunar regolith and helium-3. What is the lunar regolith? Simply put, the lunar regolith is like the soil of the moon. The soil of the moon. So if you look at this picture, these are AI generated images. You can see a rover excavating the lunar soil. So you can also see this astronaut uh, uh, building a ridge with the lunar soil. Just think about it as the lunar soil, and probably this is a AI image. This is an AI image, so they use it to build a house. So, but unlike the Earth soil, okay, which has water, the lunar regolith has no water. Okay, it has no organic material, like it doesn't have dead plants or animals or even microorganisms. The lunar regolith is made up of crushed rocks, dust, and tiny glass beads formed by meteor impact. So as these are AI images, here is a real picture of an astronaut digging into the moon to excavate some lunar regolith. This picture is a live picture taken when astronauts were traveling to the moon in the 1960s and 1970s. So I just want to let you know that the lunar regolith is simply the lunar soil. So I'm going to be using them in my talk going forward. So origin of the lunar regolith. Let us discuss the origin of the lunar regolith. Now, to understand it, let us let us go back to how Earth soil is created from our secondary school. How Earth soil is created from our secondary school or primary school, I don't know. But as far as I can remember, we were taught how soils are created. So on Earth, soils are cl- created through climatic conditions. Okay, and you know that without an atmosphere, there can be a climate. Something like intense heat. Okay, when one face is facing uh one face of the earth is facing the sun. Okay, that surface gets hit uh and it expands. That is what heat does. And when it is in the night time, it contracts. So this shift, this temperature swing, um, causes um, some you know some frictional activities because they don't expand at the same rate in the interior. Okay, that can create some soil over time, and also rainfall. Rainfall when rain is falling on surfaces, rocky surfaces, they can also crystallize, if I can use that term, crystallize some soil. So they affect how fast rocks break down. And also, soil can be created through uh, organisms, living things. Like, for instance, humans. We are always involved in mining activities, and digging the ground. Okay, so these processes can create a soil. Animals too, when they want to build their nest in a on the ground or on a rock, they have to dig. Okay, so those activities create soil. Even microorganisms, they burrow into the ground. Okay, uh, those activities can help to break down things. So that is how soil is created on Earth. But on the moon, there is no atmosphere, so there's no climate, and there are no living organisms in the soil. There's no humans. There's no living, both macro and micro, living on the lunar surface. So how is the soil created? Lunar soil created. So so for the lunar soil, there are four processes that can create them. First, one of them is the micrometeorite impact. Micrometeorite impact. The micrometeorites are these tiny space debris from the solar system. Those kind of things that causes um, shooting stars on Earth. Okay, the reason why we can see those shooting stars is because of our atmosphere. Without our atmosphere, they're going to land on the surface. Okay, but on the moon, there's no atmosphere, there's no magnetic field, so nothing is stopping them. So they are always running down on the moon and impacting the surface and creating the lunar soil. So you can see the kind of simulation here, although it is exaggerated, but this is how it works. So through this process, about 60 to 70% of the lunar soil is created. So we also have the solar implantation, the solar wind implantation. So we have these charged particles being ejected from the sun. Okay, they move into the universe. They move, and for those that have magnetic field, they can penetrate, just like Earth. They can penetrate Earth, but for the Moon, which has no atmosphere, no magnetic field, they get embedded into the lunar soil, which is the liquid, and becomes part of it. So these solar wind implantation contribute to about 10 to 15% of the lunar liquid. Then how about thermocycline, which contributes to about 5 to 10%? So extreme hot temperatures, like when the moon is facing the sun. When the moon is facing the sun, the side that is facing it can get as hot as 127 degrees Celsius. And when it is not facing the sun, it can get as cold as minus 173 degrees Celsius. So this kind of change in temperature can swing fracture rocks over time, and that can create the lunar regolith. I also mentioned that this kind of process also creates even Earth soil. Okay, so it also creates on the moon. We also have the moon quakes. I will I'll talk about it in my in this lecture later. So importance of the lunar regolith. The lunar regolith is important because it preserves billions of years of solar system history. The samples has a record of impact events. It has a record of impact events and space weathering processes. Also, there is oxygen on the moon. There is oxygen on the moon, not in the atmosphere, but oxygen buried in the lunar regolith. It Oxygen exists there, not in the pure form, but in the oxides. It is mixed with other elements, like you have silicate oxide, you have iron, you have titanium oxide, and through some electrolysis process, you can extract this oxygen from the moon. So there is oxygen on the moon, okay? And also, there are metals mixed up with this lunar regolith. Iron, metals like iron, titanium, aluminum, and many more. And they are used for construction materials and building machine parts. So there is also an element called helium-3, which I'll talk about. So which is implanted by solar wind and useful for fusion nuclear energy. Then there is also water that exists as ice in the poles on uh, on the moon. This existed is mixed with the lunar regolith. So and there are many more undiscovered minerals, many more undiscovered minerals. So back in 2022, back in 2020, some uh, Chinese astronomers or space scientists returned some lunar samples. They studied it and they discovered a new mineral. So you see, the moon remains largely unexplored. Remains largely unexplored. So in 2022, they announced it. So you can see the news here. Chinese scientists discover new mineral on the moon. I said new mineral and not new element. They are different things because element is it's a unique entity where minerals is a mixture of elements. So they discover new elements. So it means that if we all put our hands together and if all nations focus on the moon, we can make even more discoveries. And future experiments will test growing plants in the lunar surface. So these are the reason why the lunar regolith is important. So now helium-3, what is helium-3? Uh, some people call it helium-3 energy, but it is not an energy. Helium, let us start from helium. Helium is a chemical element, the second in the periodic table. It is classified as a gas and an inert gas. Okay, so it has a twin. We have helium. The normal helium we know it is having two protons and 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 two neutrons. So that is helium-4. You can call it helium-4. That's the normal helium we know. Then helium-3 is a twin brother to helium-4, but it has only one neutron, two proton and one neutron. But because of these uh, three, uh, let me just say, because of this one missing neutron, it is variant from this one. Okay, not chemically, but okay, sometimes chemically, but it is lighter. Let me just put it this way: it is lighter than its counterpart. It is lighter, and also it is non-radioactive. It's a non-radioactive isotope of this. So, but why is this chemical element so interesting? Why is it getting all the nations crazy about going to the moon? Because that's why they all want to go to the moon. Helium-3 is exciting because it is seen as a potential fuel for nuclear fusion. You know, in nuclear physics, there are two kinds of nuclear reactions. So we have nuclear fission and nuclear fusion. Okay, so all the power plants we have on the planet generating nuclear energy are all nuclear fission, and they work by splitting heavy elements, radioactive elements like uranium, uh, into two. When that is done, it emits radiation, which it is converted to electricity. Afterwards, it undergoes some processes. But the whole thing is that you create energy, and you create two other lighter elements which are radioactive, or I can call them radioactive waste. And this radioactive waste is a problem in nuclear energy generation. Okay, but now nations are now researching on nuclear fusion. the nuclear fusion process. This is a process where you bring two light elements like hydrogen or helium or lithium, just any of these light elements. If you bring it together, through nuclear reaction, they're gonna. So you can see the reaction here. This is deuterium and this is helium-3. Okay, so if you bring that together, that would give you normal helium energy and a proton. But here you see no nuclear waste. There's no nuclear waste. Doesn't give rise to nuclear waste. Okay, so this is the process through which the sun generates its own energy through nuclear fusion. So, but the whole thing is about nuclear fusion. It gives more energy. It gives more energy than nuclear fission, and also there's no nuclear waste. So, so uh, fusion using helium-3 uh, could produce enormous amount of energy, clean energy with almost no radioactive waste, like I said before. So that is why everybody is crazy about it. Now, why look for it on the moon? Why look for it on the moon to start with? Okay, now helium-3 is extremely rare on Earth. Okay, that is why we are looking for it on the moon. But on the moon, it's been deposited over billions of years by the sun's solar wind. You understand? So those constant stream of charged particles, electrically charged particles from the sun. And on Earth, Earth has a magnetic field around it, a global magnetic field around it, and also atmosphere. So because of that, these helium-3, when they are coming out of the sun, they are usually charged. So they are usually affected or deflected by the Earth magnetic field. But on the moon has no magnetic field, it has no atmosphere. So they get absorbed and get embedded on the moon's soil. So over billions of years, these element isotope has accumulated on the moon. Now, research has estimated that there could be between 1 to 5 million metric tons of this helium-3 spread across the lunar surface. I don't know boy with numbers, but I did some calculation that say, okay, let us use the 3 billion. If we extract 3 billion, how long will 3 million, 3 million metric tons will last us? So I did some calculations. The total energy consumption of the world, if we are to replace them with this nuclear fusion with helium-3, if we are to replace it, even uh, accounting for the increase in the population in the future, if we ever do that, the duration of 3 million metric tons will last for us is about 7,858 years. 7,853 years. That's a lot of years. That is thousands and thousands of years. So just with 3 million metric tons. So that should show you an idea of how abundant it is on the moon. It is so much on the moon. That's why nations are trying to they are falling on top of themselves to extract it. Apart from energy, it's also important in quantum computing, in quantum technology. So many usefulness of this helium-3. That is why China, Russia, America, they are all India, they're all falling on top of themselves to explore it. So let's talk about some moon's physical properties. Like I said, I don't want to bore you with numbers. I have just done the calculations for you. By volume, if we if you bring 50 moons, they can feed into Earth. If the if the moon were if the Earth were to be a hollow sphere, you can stack 50 moons inside it. So that should tell you the ratio of the volume between the moon and Earth. Earth is quite big. By mass, by mass, 81 lunar masses is equivalent to one Earth mass. So that means in terms of mass, 81 times the lunar mass will give you Earth mass. So it means that the moon is just barely 1% of the mass of Earth. So mass, it has no weight. It has no weight. So in terms of surface gravity, the acceleration due to gravity. So the moon is just 1/6 of Earth's gravity. 1/6 of Earth's gravity. And that has to do with affect the escape velocity. Okay. So for instance, um, the escape velocity on the moon is about 2.38 kilometers per second, which I've converted because I like to relate things to the speed of sound or the speed of light. But in this case, I related it to the speed of sound, and that is approximately 7 times the speed of sound in air. So that escape velocity of the moon is approximately the speed of sound in air. Okay, which is much lower than Earth 11.2 kilometers per second or 33 times the speed of sound. So they are completely uh, incomparable. So because of this low gravity, this low surface gravity on the moon, you can jump 6 times higher on the moon. You can jump 6 times higher on the moon. You can walk and run faster on the moon. Okay, and also the tallest mountain on the moon is called Mount Huygens. It has a height of 5.5 kilometers. Okay, although Mountain Everest, which is the tallest mountain on Earth, is taller than it. But Moon has a lot of tall mountains, a lot of tall mountains. Okay, so because of this low gravity. So here's a picture of that mountain, the tallest mountain on the moon. And mind you, the process of mountain formation on Earth and the moon are different. On the Earth there is tectonic activities, but on the moon there is no river or water. So most mountains are from huge asteroid impact in the past. So how about the atmosphere? The moon's exosphere, as that is the moon's atmosphere, has about the same particle density as the ultra high vacuum we can create in the top lab on Earth. Let me rephrase what I said. A vacuum, as we know it, is a region of no air. Okay, but in reality, it is not possible to create 100% vacuum. So even if you have created a vacuum, there will be some particles inside, okay, in the air. There will be some particles. So the particle densities will be so diminished. Okay. Now I'm telling you, the the highest vacuum that we've created on Earth in our best labs on Earth has the same particle density as the moon. So that goes to tell you that the moon is a vacuum. The moon is a vacuum, no air. But so that little particle density that we have detected so far, we have detected hydrogen, we have detected helium, we have detected sodium, we have detected neon, potassium, argon. So, but they do not make any true atmosphere of the moon, okay? And also exert pressure on the moon, which is about 1 trillionth of Earth atmospheric pressure. But the consequence of the lack of atmosphere on the moon is, first of all, footprints can last for millions of years. Footprints, astronaut footprints, or even asteroid impacts that happened millions of years are still visible. You can see them because there's nothing wiping the surface off. Just like Earth, if you walk on the surface, okay, over time, over a few days, water or wind is gonna blow and cover it with debris, okay, and level everywhere. So that is why we can see footprints of ancient people. Okay, but on the moon you can see the footprints of of astronauts that worked on the moon over 50 years ago. So, and also there's no sound transmission on the moon. There's no air sound transmission. Okay, but sound can transmit through the ground. That would be just an obvious vibration, and also water. There's no water, so in air there's no sound transmission. If you want to communicate on the moon, you have to use radio wave, like what the astronauts use. So during the time astronauts landed on the moon in 1960s and 1970s, they did the famous Galileo experiment. Let me show you the experiment. So here is the video. This is a video of one of the astronauts on the moon. He's having a feather in his hand and a hammer. So Galileo performed this experiment in the Leaning Tower in Italy. So the experiment was to prove that all objects fall at the same rate, no matter their weight. Okay. No, this is not what we are used to. On Earth, we are used to heavier objects falling faster than lighter ones, and that's because there is air restricting the lighter ones. But with that air, all of them are going to fall at the same rate as this astronaut who experiments right now. You see that? Because the moon is a vacuum, so he did that and it worked. So that is the famous Galileo experiment. So before I leave this slide, I want to mention that a day on the moon measured as from sunrise to sunrise, that is how also measured on Earth, 24 hours, okay? A day on Earth is 24 hours, but a day on the moon measured from sunrise to sunrise lasts for 29.5 Earth days. 29.5 Earth days. So this is going to be very important in my next slide. So let's go to the next part. So let's talk about the far and near sides of the moon. The far and near sides of the moon. So the near sides of the moon simply refers to the side we always see from Earth. The side we always see from Earth. You know, we always, from time immemorial, even in the ancient times, one side is always facing us. One side of the moon is always facing us. All sides of Earth. If you're on Earth, you can see the all sides of Earth. Okay, but for us on Earth, we can only see one side of the moon, and the reason because the moon is tidally locked to Earth. Okay, it's called tidal locking. I've explained it in my last lecture in Introduction 1. Explained the physics. So you go look it up there. So let me play this video. I show this video too. Okay, if you're on the moon, you can see all sides of Earth, but if you're on Earth, you can only see one face of the moon. So this process is an interesting natural phenomenon. We call it tidal locking. So that's why we see one face, and that face we see, we call them the near side of the moon. Now, how about this other side here, the far side? So the far side of the moon. So this refers to the side that is forever locked away from us due to this moon's tidal locking. Okay. Now, some people erroneously call this the dark side. They assume there's no light hitting the surface, hitting that far side. Okay, but there's light. Like I said, moon, uh, moon makes one spin in 29.5 days. It means that it is spinning, right? So, and as it is spinning, all the surfaces are getting radiation from the sun. So it is actually getting lit. So it's it is being irradiated by the sun. So stop calling it the dark side. It's called the far side. Use the right term, the far sides of the moon. So the only thing that we just can't see, and the fact that we can just see doesn't mean that it doesn't exist. So, but this far side is much more created. I mean, there is more craters and rugged places on it. Okay, and it has fewer mareas and more highlands. We only discovered it in 1959. I mean, humanity discovered it in 1959 when the Soviet Luna 3 probe sent back the images. Now, at this far side of the moon, you can see the South Pole Icon Belt, which is the largest asteroid impact craters in the solar system, which stretches to about 2,500 kilometers across and 8 kilometers deep. I showed the pictures in my last lecture. No human has ever set foot on the far side of the moon. China's Chang'e mission in 2019 was the first to land a spacecraft on the far side. Now, radio astronomers they like this they love this far side because it's shielded from Earth radio noise, and it's a perfect spot for a future radio telescope. So here's a picture of the far side of the moon, and you can see this image was taken by a spacecraft. Okay, it was taken by a spacecraft during the 1950s or 1960s. Okay, so taken by a spacecraft. So, and you can see that it is being irradiated by the sun. It is not dark, so you have no reason to call it the dark side of the moon. So here is the let me here is the picture of the near side of the moon, the one we know, and the far side, side by side. So that looks much different, very much different. Which side do you prefer? Me, I still prefer this side, facing out. So we cannot see here unless you send a satellite. So here is the picture of the moon. Okay, 360. Although this is not real, this is not how the moon rotates because we can't even see it. So these are different images or pictures taken that were combined together. I know computer can do many things, so that's why you can see that. All right, so now let's talk about the moonquakes. What are they? What are moonquakes? Just like earthquakes, we have moonquakes. So at least most of us can relate to earthquakes. So we also have moonquakes. We also have moonquakes. So moonquakes are shaking or trembling on the moon's surface, just like earthquakes. Okay, but they last much longer than earthquakes. Okay, simply because moon has no water. Water has this property of absorbing shocks. I mean vibrations. Moon has no water, so there's no way it can absorb it. So the moonquakes last much longer. You know, the water is also part of the rocket fuel. So if you observe rocket launches, you see that there's a lot of plumes, a lot of fumes coming out. And the reason because part of that whole thing is water to absorb shock, vibration from the rocket. So water has a property of absorbing shock. So, but the moon has no water, so it can absorb it can't absorb vibrations. So that's why moonquakes last longer. So types of moonquakes, we have deep moonquakes, which happen 700 kilometers below the surface. It is caused by tidal forces from Earth to gravity. We also have the shallow moonquakes, which is stronger than the deep moonquakes, but less frequent. It happens between 20 to 30 kilometers below the surface. So this kind of moonquakes could crack rocks and shift the ground significantly. So we have the thermal moonquakes caused by surface expansion and contraction that I've talked about before when the sun rises or sets. So these huge temperature swing. So we have meteorite impact, the huge meteorite impacts, those big ones, those big guys. So when they land on the moon, they can cause meteorites. They can cause moonquakes when they land on the surface. So the instrument we use to measure these moonquakes is called the lunar seismometer. They were placed on the moon by the Apollo astronauts at different sites by different missions on the moon's surface. So they are used to detect moonquakes, meteorite impact, thermal movements, and even vibrations from lunar model landings. So here's a picture of the moonquakes. Sorry, of the seismometer, lunar seismometer. So how about lunar poles and water ice? Just like any other celestial body, just like any other celestial body, like the sun, the planets, anything that is round there. There are poles on the moon. Also has poles. Moons, not just the moon. Our moon. Moons have poles. All the moons have poles too. So the North Pole and the South Pole. But for our moon, the moon, It has water ice. Water ice have been detected at these poles by NASA and Indian missions. Uh, so these have been detected mainly at the permanently shadowed craters at the south and north poles of the moon. And why is that so special? It's because the tilt, the tilt of the moon with respect to the sun is around 1 degrees. It means they're not getting enough sunlight. So even the parts that are getting it are getting the light in the horizontal direct, like horizontal form. Okay, so the consequences of that is that there are craters that are permanently shadowed, like for billions of years they have never received sunlight. Okay, so water, um, water that were formed billions of years ago remain frozen in those regions. So we hope space missions are being sent there to explore this water because the water will be useful during astronauts lunar missions. Well, want to build a permanent base. We don't have to take water from Earth. We can extract the water from the moon. So here is the picture. So here is the South Pole, and here is the North Pole. So how about Earth magnetic? The moon's magnetic field. You remember, the Earth magnetic field comes from molten iron at the outer core, right? So look at the Earth's interior. So you have the solid inner core, you have the liquid outer core. So it comes from there. Well, what is the actual physics playing out in generating magnetic field? So let me talk about the actual physics. Charged particles, when objects are heated, they get ionized. Okay, so they become charged, electrically charged, either positive or negative. Okay, when they are in motion or are in motion, they um, they generate magnetic field. So you have a lot of these charged particles in motion. So you have you have an overall magnetic field configuration. So that is why there's magnetic field around wires. So for under the Earth, these charged particles are moving in one direction. So they generate a very powerful magnetic field around Earth. So that's where the magnetic field is coming from. So we call it the magnetic dynamo. The magnetic dynamo. But on the moon, as of today, the moon has no such active dynamo. Its core is much smaller and mostly solid and geologically dead. So no large-scale magnetic field wraps around the moon. So you can see it here. It has a solid inner core and a partially melted outer core. So partially can also generate some few units of magnetic field. So but just partially. So what about the past? I mean, what about the past? Now, lunar rocks brought back by the Apollo mission astronauts showed magnetization. They display some element of magnetization, so which is an evidence they formed in a magnetic field. So it means the Earth was once in a magnetic field. And also, research suggests that around 4 to 3 billion years ago, the moon had a magnetic dynamo producing a field possibly as strong as Earth today. But that field faded out over time, maybe because the moon's small size causes core to cool and solidify too quickly to sustain a long-term dynamo. So that is why, because of the small size. But even though the moon has no global magnetic field today, there are some localized magnetic regions that exist around it. These areas can deflect the solar wind locally, creating a tiny mini magnetosphere just a few hundred kilometers across. So you can see it. You can see it has a local. Does not have a global magnetic field. So now to the last part of this lecture, which is gonna take some time because I'm gonna show you a lot of pictures. Human lunar exploration. It simply refers to the mission where astronauts travel to land on and explore the surface of the moon. It's one of humanity's most iconic space achievement and a key stepping stone for future exploration beyond Earth. So the history of lunar missions. I mean, lunar missions. It started from the Soviet Union in the 1959. They sent the first lunar spacecraft called Luna 2. Okay, but it couldn't land safely. It impacted. It landed as an impactor. Okay, that is now I want to tell you that is how it starts. For every nation to have a successful lunar mission, their first trial usually begins with an impactor because you are still perfecting your technology to be able to land on the moon. It is not easy to land on the moon because there's no atmosphere. Landing on the moon is not like landing on Mars or on Earth. So the technology hasn't perfected. So you're going to see that. I'm going to show you more of these examples. Most countries that enter the lunar mission race start out with an impactor. So like this is the first Russians. So now, after the Russians, then you have the Americans through the Apollo missions to the moon. So the Apollo mission includes several missions, about 9, that reached the moon, each with a crew of 3 astronauts. But some astronauts flew to the moon more than once, okay? So I'm going to give you a breakdown. So we have the Apollo 8. So it started from Apollo 8. So most people do not know that. They thought it started from Apollo 11. No, it started from Apollo 8 in the 1968. So that was the first crewed mission to orbit the moon. There was no landing, just to orbit the moon, just to test out technologies, okay, before the actual event. So there were 3 crews. We have, sorry, 3 crew. Frank Borman, James Lovell, Williams Anders. Then we have the next year, 1969, Apollo 10. They did their dress rehearsal for the lunar landing. They orbited just like the first set. There was no landing. There were 3 crews. There were 3 crews. Then we have Apollo 11. That same year, Apollo 11. So, they were the first. They were the first to land. Um, the first set of astronauts that landed on the moon. That was the Neil Armstrong and Buzz Aldrin and Michael Collins. He stayed in the orbit. Okay, 2 people landed while this one stayed in the orbit. Then we have Apollo 12, 1969, that same year, second landing crew. Some people thought that it's only Neil Armstrong. There were several missions that landed on the moon, so take note of that. So Pete landed, Alan landed, and Richard uh, Gordon stayed in the orbit. So we have Apollo 13. They were supposed to land in 1970. They were supposed to land, but there was an accident that happened. There was an explosion. So the the crew flew around the moon without entering the orbit. Okay, but they came back safely. But they were supposed to land, but they couldn't land. They couldn't even orbit, but they flew. They made a flyby and came back. In the 1971, the third landing happened. So you have Alan Shepard landed and Michelle landed while Rosa standing in the orbit. So that's the standard practice. Someone has to remain in the orbital module while 2 other people would land on the surface. Okay, that is standard practice. Then Apollo 15 in 1971, that was the fourth landing. And Apollo 16, 1972, the fifth landing. And the Apollo 17, the sixth and final landing. So, let me share some videos. It is
And
quite
we
long.
haven't seen to the bottom. I think we'll get a chance to look further down.
So you can see the lunar regolith, the soil, the lunar
I
soil.
told him you were. Up.
So you see that the astronauts are struggling to maintain
We
balance
see that one went all the
because
way in.
of the low lunar
Not
gravity. They're
quite.
not used to it, so that's why. They're almost flying because of the low lunar
Flight,
gravity, the low
Go.
surface gravity.
But there he is, all but about
here shortly.
5 inches.
Okay, John, can you
Okay.
stand by for a feed water tone?
That one was okay, and John, stand by for a feed water tone.
This video is quite long. You can find it on YouTube. It's about 4 minutes long, so I'm going to just cut it short. But I've just shown you. So history. Now, doing these several missions, like I said before, they left some equipment like the lunar seismometer and also an equipment called the reflectors. These reflectors is used for laser ranging to measure the distance between the Earth and the Moon. So look at it here. Several of them were dropped, and look at these footprints. They are still there. So here are the sites where the Apollos landed. There are different sites they landed. There are 6 sites. 6 sites. So here is the how the laser ranging works. So you aim at these retroreflectors on the moon. You have to aim at it. You don't have to send lasers anyhow. If you aim at it, at the one of those retroreflectors, you send out these lasers. Then they get reflected back. Sorry, they get reflected back in the same parallel direction you sent it. So if you send it from this direction, they get reflected back. So that is how it is built. Although there are other methodologies involved, okay, you still have to do your research. It's very interesting. So from here, you can calculate the distance from the distance between the Earth and the Moon. So here is how it works. You send radiation, a laser, and it's get reflected back. So during their return, they brought back some lunar rocks and soil worth about 300, weighing about 382 kilograms in total. So many samples. So now let me do a statistical analysis of all the Apollo missions to the moon. So the mission started in 1968 and ended in 1972. That is 4 years. And during these 4 years, there were 9 missions. 9 missions. 6 were landing missions, where 3 are non-landing missions. Okay. So the total number of visiting astronauts that visited the moon is 24. 24 unique individuals across the missions. You know, some of them visited more than once. So, but I'm telling you, 24 in total, like unique. Okay. Now, astronauts that walked on the moon are 12 out of the 24. And we call them the moon walkers. The moon walkers. So just take note of that. So there are only 12 of them that landed. So that represents 50% of the astronauts that visited the moon. Okay. So in terms of frequency distribution of the years, so in 1968, well, there was 1 mission. It wasn't landing. Okay. 1969, there were 3 missions. Okay. Then 1970, there were 1 mission. 1971, 2 missions. 1972, 2 missions. So the mode is 1969. 1969, there were 3 missions. So in terms of the time span, like I said before, the mission spanned for 4 years, starting from December 1968 to December 1972, which is all for 48 months, depending how you want to calculate it. Now, out of the 24 astronauts, only 6 are alive today. Only 6 are alive today. So we have Buzz Aldrin. He is 92 years old today. They are quite old. We have David Scott. Is 92 years. Sorry, Buzz Aldrin is 95, but David Scott is 92. Charles Duke is 89. Harrison uh, Harrison is 89. James Lover is 97. And we have Fred Hayes is 91. So they are quite very old. Others, there are even 2 of them that died I think in 2023 or 2024. So not just getting old. So you gotta reach out to them to appreciate the hard work, the effort, and inspiring the next generation. And by the way, it has been 50 years since this happened, since the last mission. It was only the Americans that landed on the moon. No other nation did. No other nation did. Only the Americans. Russians were sending probes. But let me talk about countries and their lunar probes. I'm going to focus on the uncrewed missions, to the moon. I'm going to focus on the uncrewed missions, missions without any humans. So it could be probes, it could be rovers, it could be satellites. So with the Soviet Union down Russia, they started out. They were the first in almost everything, not just in the lunar missions. The, but they didn't want to send any humans because Americans had already done it, so there was no need for them doing it. But they continued to explore the planet. So something like Luna 2 in 1959, the first probe to impact the moon, I mean impactor. 1959 again, the same year they sent the first photograph of the moon's far side. So that through a flyby. So we have Luna 9, the first successful soft landing. So they started with hard landing, impactor, and they have soft landing, successful soft landing on 1966. So in Luna 10, 1966, the first to enter lunar orbit. So first in almost everything, we have Zoid 5 spacecraft, first to carry life forms, tortoises, around the moon. Luna 16 in 1970, the first robotic sample return missions in Luna 17, 1970 again. They deployed the first robotic lunar rover. In 1976, um, that was their last mission before the fall of the Soviet Union. So in total, they had 8 lunar missions. That is quite understandable because the Soviets has fallen, and now we have Russia. So here are pictures: Luna 2, Luna 3, Luna 9, Luna 10, Zode 5, Luna 16, Luna 17, and the last one, Luna 24. Now, how about the United States? United States started in 1959 with the Pioneer 4. It was an early flyby through, which was partially successful. Okay, then we have the Range 9 in 1964. That was the first U.S. deliberate impactor, and it sent back images. Then in 1966, just 2 years after, they had their first soft landing. Okay. Then in 1966 again, that's the first U.S. lunar orbiter. Then after that, they never sent any uncrewed missions to the moon. They never sent, even to today. Okay, till 2024, we had these private companies coming in now, private companies. So, so they sent 2 spacecrafts to the moon, to the southern pole, to explore the lunar ice. So here are the pictures. So here is picture of Range 7, Surveyor 1, our Lunar Orbiter 1 mission. So you have the Intuitive Machine IM, that is 1, Intuitive Mission 1. So Intuitive Mission 2, so the same company just sent those to explore the water ice on the moon. Then we have the Japanese, they entered the race in 1990, the first Japanese lunar probe orbiter. Okay, so we have the Kaguya in 2007, lunar orbiter to map the Apollo's landing sites. And we have soft landing, precision landing demonstration by Slim. So in total, they have 3 missions. So here are the pictures here. Then we have the Chinese. So the Chinese got in 2007, and they have had very successful lunar missions. None of them has ever failed. So you have in 2007, they sent the lunar orbiter to map the moon. Then also 2010, they sent a spacecraft, Chang'e. Sorry, I forgot to include it here. Chang'e in 2010. Then you have Chang'e 3 in 2013. Did a soft landing with the U2 rover. Then 2019, Chang'e 4, first soft landing on the moon's far side, the Icon Belt, with Yutu-2 rover. And 2020, COVID-19, Chang'e 5 returned samples, return missions from near side. So that is the sample they used to discover the new mineral that I mentioned earlier. We have Chang'e 6 in 2024, sample return from far side, Apollo crater. So in total, they have 6 missions to the moon, and they just recently got in. So here are some of the pictures. Sorry, I didn't include Chang'e 2 in these slides. So here are Chang'e 6. So India got in 2008, lunar orbiter with moon impact probe. It's a deliberate impactor. That's in 2008, sorry. Then we have 2019, they had a successful lunar mission, but the lander failed to soft land, but the orbiter is successful. We have Chandra 3, the fifth Indian soft landing near lunar South Pole with lander and rover. So in total, they have 3 missions. 3 missions. So here are the pictures. So others, we have others that have been sending 1 missions each. We have the European Space Agency for representing the European countries. In 2003, they sent the Smart 1, a lunar orbiter. Israel too, in 2019, it was a private mission. Okay, it was supposed to soft land, but it failed, so it had a hard landing. Well, before that, they took pictures. So we have South Korea, Danuri in 2022, lunar orbiter. They have a United Arab Emirates. Their mission was part of the Japanese iSpace Hakuko R mission, which impacted the moon. So the mission failed. So we have Pakistan iCube Karma in 2024, lunar orbiter, part of China's Chang'e 6 mission. So in total number of countries and organizations that have sent a probe to the moon is 11. So that makes the moon the second most explored celestial body after Earth. Earth is the first, moon is the second, and that shouldn't surprise you. So here are the pictures. Pictures from, this is Korea, this is UAE, Pakistan. So how about the future? The future lunar exploration. So in the future, we're going to have the Artemis program. Okay, we have uh, plans to establish a sustainable lunar base for long-term exploration. Then we need to build the next space station called the Lunar Gate Space Station will be built around the moon. Will be orbiting the moon, not the Earth. Or the Earth will still remain there. The one we have will be retired in 2030, and new ones will be built by private companies, maybe, but that's it. So the Artemis program aims to bring the next humans, including the first woman. No woman has ever landed on the moon. The first woman and the first person of color on the moon by late 2020s. So here is the future. This is a graphical image. This is not a real. Some people believe that there are hotels on the moon, but that's a false. Okay, these are, what people use computers to design, not that are real. Okay, that is just an architectural work. That is how it is done. But that's it. So a future lunar base will be for science and for tourism. And like I said before, the next space station called the Lunar Gateway space station will be around the moon. So here is a sample of it. So why do we want to go back to the moon? Why spending these billions of dollars? Why do we want to go back to the moon? And the answer is we want to explore the resources. We want to explore the resources, the the undiscovered minerals and helium-3 and water ice and everything. And going to the moon will prepare us for the Mars missions, okay, to establish a base on the Mars. And we want to go to these celestial bodies because we want to advance science and technology and international cooperation. So thank you very much. You can drop your questions and I'll respond to them. Thank you, and thanks to the Free Astro Science for sponsoring this lecture episode.